When people ask who invented the camera, most expect a single name and a single date. The truth starts earlier, in a dark room with a small hole and a patch of light that looks like magic until you understand it. Long before anyone could fix a picture to a surface, there was the camera obscura, a dark space where light passes through a tiny opening and projects the outside world upside down on the opposite wall. Philosophers knew it in the ancient world. Artists used portable versions in the 1600s and 1700s to help them draw what they saw. The image was real, but it vanished the moment the light stopped. The problem was never seeing the picture. The problem was keeping it. In the 1700s, natural philosophers noticed that certain chemicals changed when exposed to light. Johann Heinrich Schulze mixed silver salts and watched them darken. Carl Wilhelm Scheele studied how silver compounds reacted to light. They could make ghostly images, but they had no way to stop those images from continuing to darken and disappear. The missing step was fixing, making the image stay. Enter Joseph Nicephore Niépce, a French gentleman who left public office to experiment at his family home. He knew the camera obscura could form an image. He knew silver salts reacted to light. What he needed was a surface and a substance that would respond slowly and then stay. His early tries in 1816 used paper coated with silver chloride. He managed to create negatives. Light areas turned dark, dark areas turned light, but the pictures kept changing and faded away. They weren't permanent. Then, Niépce tried something different. Bitumen of Judea, a pitch-like material dissolved and spread thinly on a plate, often pewter. Bitumen hardens when exposed to light. Where the light is strongest, it becomes tough. Where the light is weakest, it stays soft and can be washed away with solvent, leaving metal exposed. That meant the scene outside his window could etch itself as a pattern of hardened pitch and bare plate. It wasn't fast, it wasn't sharp, but it lasted. In the mid-1820s, probably 1826 or 1827, Niépce produced what many historians call the first permanent photograph, view from the window at Gras. It took hours of exposure. The rooftops looked strange because the sun tracked across the sky while the plate slowly registered light. The image is small and grey, but it is fixed. It does not vanish when the door closes. Niépce called his method heliography, sun writing. He kept refining it and wrote to other experimenters, including a Parisian scene painter and showman named Louis Daguerre. Daguerre was fascinated by light and display. He ran the diorama, where huge hand-painted scenes shifted with changing illumination. He understood spectacle, and he understood that if someone could make the camera's image permanent and faster, it would change everything from portraiture to science. Niépce and Daguerre became partners. They exchanged letters and samples. Niépce kept searching for better chemistry. He felt silver held the key. In 1833, he died before the process was perfected. Daguerre carried on. He worked with silver-coated copper plates and discovered that a brief exposure could create an invisible, latent image. He found a way to bring it out. Warm mercury vapor developed the picture, and a wash stabilized it. At first, operators used common salt. Very soon, sodium thiosulfate, hypo, became the standard fixer that stopped unexposed silver from changing further. Suddenly, images didn't need hours. They could take minutes. They were detailed, mirror-like, and, when properly fixed, permanent. In 1839, Daguerre's method went public, the daguerreotype. Paris newspapers shouted the news. Crowds lined up to sit for portraits. The daguerreotype caught every hair, every wrinkle, every seam in a jacket. Each plate was a one-of-a-kind image on metal. No negative, no copies. But the realism stunned people. Governments offered honors. Museums scrambled to collect samples. At the same time, daguerreotypists learned the job had risks. Mercury had to be heated in sealed boxes with good ventilation. It was a craft and a hazard, and still the studios multiplied. Across the Channel in Britain, William Henry Fox Talbot had been on a similar path. Frustrated that he could not draw with the camera obscura as well as he wished, he tried to let the light draw for him. He coated paper with silver salts and made images he called photogenic drawings. Then he made the crucial leap, the negative. On paper, the tones reversed. Light became dark, but from that one negative, you could print many positives. Talbot's calotype, announced soon after Daguerre's breakthrough and patented in Britain in 1841, did not have the metallic crispness of a daguerreotype, but it offered something Daguerre's could not: reproducibility. One negative could make many photographs. That idea would define photography's future, even if the patent slowed adoption in Britain at first. Another key figure arrived almost immediately: Sir John Herschel. He coined the word photography, introduced a practical vocabulary for negatives and positives, and showed that sodium thiosulfate could act as an effective fixer. With fixing in place, photographs stopped being chemistry tricks and started being records. So when was the camera invented? If you mean the moment a camera produced a permanent image, you point to Niépce and his bitumen plates in the 1820s, after trials that began in 1816. If you mean the first practical process the public could adopt, you point to Daguerre in 1839. If you mean the first negative to positive system, the logic modern photography uses, you point to Talbot soon after. And behind them all stands the camera obscura, centuries old, quietly waiting for chemistry to catch up. What about the claim that famous painters used a camera? The camera obscura was a known tool in the 17th century. Some art historians argue that artists like Vermeer may have used optical aids to study light and perspective. Whether they did or didn't, the point stands. Cameras weren't born from nothing. The box and the lens came first. The fixing came later. By the 1840s and 1850s, the story accelerates. The collodion wet plate process put sharp glass negatives in photographers' hands. Albumen paper brought that detail to the public in warm, glossy prints. Portrait studios appeared on main streets across Europe and America. People who had never been able to afford a painted likeness suddenly owned images of themselves, their families, their homes. Science used photography to record the surface of the moon and time the transit of Venus. Reporters carried cameras to wars. Botanists and archaeologists built visual archives. The camera stopped being a curiosity. It became a tool. Speed changed what was possible next. In 1840, mathematician Joseph Petzval designed a fast portrait lens, manufactured by Voigtländer, that swallowed light instead of sipping it. Exposure times dropped dramatically. Sitters stopped freezing for minutes and started breathing again. Around the same time, not every path ran through the same door. In 1839, Hippolyte Bayard showed a direct positive paper process in Paris. It made a single unique print without a negative. Bayard lost the publicity race to Daguerre and answered with his famous Self-Portrait as a Drowned Man, a reminder that inventions are ecosystems, not podiums. Practice split into branches. Frederick Scott Archer's collodion process, 1851, produced crisp glass negatives and also enabled ambrotypes, images on glass, and soon after, tintypes, ferrotypes, on thin metal, cheap, durable, and quick. Tintypes took photography to fairs and campsites. In 1854, André Adolphe Eugène d'Estery popularized the carte de visite, small, affordable portraits printed in batches from a single negative. Albums spread through living rooms. Celebrities and soldiers alike were collected on cardstock. Photography also learned to travel. In 1855, Roger Fenton hauled a darkroom wagon to the Crimean War. His careful compositions, like the Valley of the Shadow of Death, brought a distant conflict home. At nearly the same moment, stereo viewers turned flat pictures into depth. Charles Wheatstone described stereoscopic vision in the 1830s. By the 1850s, handheld stereoscopes made paired images snap into 3D. Parlors filled with views of mountains, streets, and ruins that seemed to stand inside the box. The medium widened beyond studios and warfronts. In 1843, Anna Atkins self-published photographs of British algae using cyanotype, creating one of the first photo books and placing a woman at the start of photographic publishing. Across the world, studios opened in port cities and capitals. Court portraits, landscapes, and scientific surveys formed local archives. Photography was no longer a European curiosity. It was a shared technology. Dry plates changed the pace again. In 1871, Richard Leach Maddox proposed gelatin dry plates. Later improvements made them fast and reliable. Photographers no longer had to coat and develop on the spot. With faster plates came faster shutters, true instantaneous exposures, and candid street scenes that didn't look posed. Then came roll film. In 1888, George Eastman sold a simple camera loaded with flexible film and a promise: you press the button, we do the rest. Suddenly, you didn't need a darkroom to take pictures. By 1900, cheap box cameras put photography into children's hands. The camera that began as a scientific instrument and a studio craft became an everyday habit. Color arrived in steps. In 1861, James Clerk Maxwell demonstrated a 3-color method using filters. Later in the century, experimenters refined dyes and screens. In the early 20th century, processes like autochrome made color practical for consumers. But the logic was already there in Maxwell's demo: split light, capture components, combine them again. Some firsts help anchor the early decades. In 1838/39, Daguerre's Boulevard du Temple recorded the first known person in a photograph, a man getting his boots shined, still long enough to register in a long exposure. In 1840, John William Draper produced one of the first detailed photographs of the moon. Each milestone nudged the medium from experiment to language. So if you want a single line to hold it all, optics made the picture, chemistry made it stay, economy and policy made it spread. That chain, from Petzvold's faster lens to Bayard's overlooked paper, from patents and prizes to pocket-sized prints, from wet plates to dry plates to roll film, turned the camera from an experiment into a habit. If you want to hold the first camera in your head, imagine 3 scenes. First, Niépce at a window, a pewter plate resting nearby, solvent in the air, hours passing while sunlight hardens a thin film of bitumen, a surface that will not forget. Second, Daguerre lifting a silvered plate from a mercury box and watching a hidden image bloom, then fixing it so it will last. Minutes instead of hours, detail so sharp it startles. Third, Talbot laying a paper negative against sensitized paper and pressing them under glass in the sun, printing out a positive. 1 negative, many prints. 3 rooms, 3 solutions, 1 invention unfolding. So, when was the camera invented? It depends on which step you think counts. The eye of the camera, the obscura, was ancient. The first permanent photograph belongs to Niépce in the 1820s, after his 1816 trials. The first practical public process is Daguerre in 1839. The negative-positive logic that makes photography a medium, not a one-off, is Talbot. Add the speed of new lenses, the reach of travel, the safety of fixing, the freedom of dry plates, and the convenience of roll film, and you see the real answer. The camera was not a single spark, but a chain of solutions: optics, chemistry, fixing, and access, linked by people who believed light could write. And ever since, it has.